So we've done expanded form, factored form, the domain, the y-intercept. Now we're going to look at the roots of the rational function. Now if you remember back from quadratics, roots are your zeros. It's where you're going to cross the x-axis. Those are the roots of the function. So for this particular type of function, for rational functions, you are going to actually, it's where y equals 0. You're going to set the numerator equal to 0 and find out what x values give you a y value of 0. So we just found the y-intercept by making x equal to 0. Now we're going to find the x-intercept by making y equal to 0. And these are actually pretty simple. So let's look at the first one. Let's look at number 1. If you look at number 1 is x minus 4 over x plus 2. Now here, when you're doing the roots, it's much easier to have it in factored form. Factored form will be your friend when you're trying to find the roots or the zeros, the x-intercepts. Expanded form or standard form is going to be a little more difficult and a little more involved. You might have to complete the square, do the quadratic formula, solve by graphing. You don't want to have to do that. So factored form is going to be ideal for finding the roots or zeros of an equation. So we're going to use the factored form since we have them both. Okay, so let me make sure I have all 10 examples here. Okay, so let's begin. Let's look at the first one. For number 1, I have x minus 4 over x plus 2. Now, what we did to find the domain is we figured out what would make the denominator 0, because we can't make the denominator 0 in a fraction. You can't divide by 0. But now what we're looking for is we're looking for when y is 0. When is the value of the function 0? When is it going to be 0 if I plug something in to this particular fraction? How do I make this fraction equal to 0? Not undefined, not with a 0 in the denominator, but with a 0 in the numerator. So what you're going to do for the roots is you're going to set the numerator equal to 0. So I'm going to take, in this particular example, I'm going to take x minus 4, which is my numerator, and I'm going to set it equal to 0. I add 4 to both sides. So my root for the first one is x equals 4. Because that is the value that's going to make my numerator 0. That's going to make this equal to 0. Not undefined like the domain with the negative 2 where you can't divide. It's going to make this fraction have a value of 0. If there's a 0 in the denominator, it's not equal to 0. That's undefined. That's no value. But you can have 0 in the numerator. 0 over 20 is 0. 0 over 5,000 is 0. As long as there's a 0 in the numerator and a real number in the denominator, it's 0. So let's look at number 2, x plus 6. So x plus 6 is my numerator. So I'm going to take x plus 6, I'm going to set it equal to 0. So x is going to equal negative 6. So that is my root for number 2. X is going to equal negative 6. And notice how my root, which is my x-intercept, I'll put a little note there. My root, which is my x-intercept, is x equals. My y-intercept is y equals. When you have a y-intercept, it's where x is 0. When you have an x-intercept, it's where y is 0. So let's do number 3. Number 3 is 2x plus 5 is our numerator. So I'm going to take 2x plus 5. Set it equal to 0. This one will be a couple of steps. Minus 5. 2x equals negative 5. I divide both sides by 2. And x is negative 5 over 2. So your root here is x is equal to negative 5 over 2. So we're finding roots. And it shouldn't be too terribly difficult to find the roots once you get the hang of it. So let's look at number 4. Number 4, we have negative 4x plus 2. Let me go ahead and number these so that you can see them a little more clearly. That's 2, and that's 1, okay? So I'm going to take negative 4x plus 2, which is the numerator, and set that equal to 0. Move the 2 over. Negative 4x equals negative 2. Divide both sides by negative 4, so x equals 1/2. So your root here is going to be at 1/2. 1/2 is what's going to make the fraction equal to 0. Okay? All right. Let's keep moving. Let's look at number 5. Number 5, we have x plus 4 as our numerator. So I'm going to see what is it that's going to make x plus 4 equal 0? Well, it's going to be negative 4. So for this one, x equals negative 4. That's what's going to make my numerator equal 0. Okay? So let's keep going. Let's look at number 6. Number 6, your numerator is x plus 1. So I want to set x plus 1 equal to 0. So I'm going to subtract negative 1 from both sides. So x equals negative 1. So x equals negative 1 is my root, or my 0, for this one. All right, number 7. For number 7, in factored form, which is your friend when you're doing roots, you have x plus 4 and x minus 2. So I've got 2 potential roots here. 2 potential roots. Now, we're going to come back and look at these roots in a minute and see whether these roots are actually probable roots or if they're not probable roots. In fact, let's go ahead and do that right now. Right here, my root is 4. When you find your root, you have to make sure that it fits in the domain. X is 4. Is 4 part of the domain? Yes, because the domain is everything but negative 2. X equals negative 6. Is negative 6 in the domain? Yes, because x equals everything but 6. X equals negative 5/2? Yes. X equals 1/2? Yes. X equals negative 4. What does it say our domain cannot contain? Negative 4. Therefore, this one is non-existent, and this becomes none. You have to make sure, and I was going to do it at the very end, but I might as well do it now because we did it at the time here. You have to make sure that whatever you choose for your root or find for your root or your y-intercept is in the domain or the range. X is negative 4, but the domain says we can't have negative 4, so we're not going to use it. So let's move on down. The next one, x is negative 1. That's a problem. Negative 1 is not in the domain. Therefore, this one is not a root. So you have to be careful with what you choose. And I want to go ahead and point that out now. I know we did that along the way with the y, so we'll do it with the x here. So let's keep that in mind for the rest of the way. So for number 7, I've got x plus 4 and x minus 2. So I'm going to set x plus 4 equal to 0. And I'm going to set x minus 2 equal to 0. This is going to give me negative 4, and this is going to give me 2. So if I look at negative 4 and 2, what do you see? 2 is not in the domain, so the only one we have is negative 4. So x equals negative 4. And that's because the 2 is not in the domain. Okay? Up here, we didn't have one because these were the only values we had. Negative 4 was the only one we found, and it wasn't in there. Here, it can be negative 4 or it can be positive 2. Positive 2 is not possible, but negative 4 is. So let's move on again. Again, we're finding the x-intercepts or the roots. It's where the fraction equals 0. But it has to be a real fraction. We can't get 0 in the denominator. So let's slide back up here. And we're on number 7. So now we'll do number 8. Fit number 8 right here. Number 8, we have x minus 3 and x plus 2. So once again, we've got 2 binomials here. Let me move this over. We've got 2 binomials. So that means we could possibly have 2 x-intercepts. So x minus 3 has to equal 0, and x plus 2 has to equal 0. So with that being said, that means x either equals 3 or x equals -2. Well, let's look down here at our domain for number 8. What can x not equal? -2. That means that this cannot be a root. However, 3 can be, because 3 is in the domain. So x is 3. Again, you're checking. We have numbers that don't end up in the domain. If they are not in the domain, they cannot be a root. They cannot be an intercept. So let's look at number 9. So I'm going to put number 9 here. Number 9 is x plus 4 times x plus 3. So once again, I'm going to set x plus 4 equal to 0, x plus 3 equal to 0. So x equals either -4 or -3. So let's look at number 9. Which one cannot be in the domain? -3. So that means that this is not possible, but -4 is. So your root is x equals -4. Now, are there going to be times where you may have 2 x-intercepts and both of them will be in the domain? Sure. But with these functions that we're practicing now, you're not going to end up with that. But it is possible. You're not always going to have to cross one out. It's not always going to happen that way. It just happens in these particular examples we have that. So for number 10, we have x plus 4. That's the only one. So we're going to set that equal to 0. So x equals -4. So for number 10, you look at your domain. It can't be -2 or 1, so -4 is good. So x equals -4. And that is how you find the roots of rational functions, which is the x-intercept or the 0 value of the function. And when you find your roots, you have to check your roots against the domain and make sure that the value you get for the root is in fact in the domain. If it is not, like in number 5 and number 6 and all of these here where we had to exclude one, for example, x equals -4, well, -4 is not in the domain. You can't use it, so you can't use x as -4. That means there's none for this one. Some of these down here, we got 2 values. One of the values was good, one of the values was not. So it just depends. You have to always check your root against the domain.